Hi, so this video is going to be looking at the relationship between ionic charges and their placement on the periodic table and how we can tell what ionic charges an individual element will have and how we can communicate that. So first off, a little bit of a reminder, all ions have charge. They could be positive or negative, and we call the positive ions cations, and you can always remember that cations are positive, and negative ions are called anions. I have no cute statement for that. We talked about this earlier in the year, and we know that ions are formed when an atom gains or loses electrons. So normal atoms are neutral, but ions are atoms that have gained or lost electrons. Now, since electrons are negative, an atom that gains electrons will become negative, therefore called an anion. So losing electrons, conversely, makes an ion positive or a cation. Really important to remember those distinctions. I'm going to use that terminology moving forward. So ionic charges in general, for the most part, metal atoms will lose electrons to form ions. That's just what metals do. Metals, when they form ions, lose electrons, which means they become positive. So you can remember that cats are metal and like throw some horns or whatever. But cats are metal, cats are awesome, all that good stuff. And again, so metals lose electrons. We'll talk about how many they lose in a moment. Likewise, nonmetals gain electrons when they form ions to form negative ions or anions. Now, the number of electrons that an atom gains or loses changes and is based upon the element itself. To do this, we're going to need the periodic table. So before you watch much further, I'm going to recommend that you take out the periodic table that you have in your notebook. If you don't have one in your notebook, grab one from up front because you are going to want a periodic table that is a reference moving forward. So how can we use the periodic table to identify ionic charges? So here's a periodic table, and I like this one because it's color-coded. It's showing the different groups of the elements. You have this already in your color-coded periodic table. And what we're going to do is we're going to start over here on the left. So here on the left, all of these ions will always form a +1 ion. That means because they're positive, they lost electrons, and because they lost electrons, they're cations. And the number there, that 1, means that when they form ions, they will always lose 1 electron, always gaining or having a +1 charge. The next group over is +2. So like beryllium, magnesium, calcium, so on and so forth. All the elements in that column will always form a +2 ion when they form ions. We're going to skip over this whole group in the middle. That skips these ones down here at the bottom, which are really kind of a breakout piece. And this brings us to the right side of the periodic table, and specifically aluminum. Now it turns out, and I'm going to put these in blue, so these metals down here, we called those on our previous activity the other metals. We're not going to worry about them for now, but aluminum we are. So aluminum, that Al, will always form a +3 ion. So far, moving from left to right, we see +1, +2, +3. And again, make sure that you have this written down on your periodic table. Perfectly reasonable questions for the next test could be, what is the common charge of a calcium ion? Anyway, so we move forward. Turns out it's really hard for atoms to gain or lose more than 3 electrons. So if you see the pattern, +1, +2, +3, that means going from left to right, that means we lost 1, lost 1, lost 2, lost 3. Really hard to do more than that. So we're actually going to skip the carbon row. So carbon, silicon, germanium, we're skipping them. They don't tend to form ions. So now we're with nitrogen. So kind of nitrogen and phosphorus, these form -3 ions. Next column, oxygen through selenium, is -2 ions. And finally, fluorine through bromine is -1 ions. That far right column, the noble gases, what they're known for is they do not tend to, fluorine through tessonine or astatine. With that last group, my apologies. That last group on the far right, the noble gases, does not tend to form ions. They don't react. So once again, no charges. So you are responsible for knowing any of these atoms that have common charges. That is absolutely something that you are responsible for knowing. So make sure that you have those charges on your periodic table before you move forward. I'm going to pause for a moment just to give you time to take care of that as necessary. I feel like I need hold music. Do, 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 do. Hold music while you write. Do, 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 do. Okay, so transition metals. So transition metals are all that stuff in the middle. That entire kind of big rows that we skipped in the middle, and most of the other metals that we kind of circled. What makes them interesting is that they actually form more than one type of ion. So unlike calcium, Ca, which always forms a 2+ ion, which means it always loses 2 electrons to become an ion, the transition metals can actually have multiple different charges. They can lose, and it's always lose because they're still metals, they can lose more than one type or more than one amount of electrons. Because of this, we have to do something a little differently with them. We can't just say, oh, I have a calcium ion, and we know that calcium will always have a +2 charge. So for instance, so here we have iron. Iron, and this is just something I know you are not responsible for this, will always lose 2 or 3 electrons. If it loses 3 electrons, we can write it like this. So the Fe is the iron, means iron, and the 3+ means 3+ charge. Or if we're writing out the name of it, we call it iron 3. The Roman numeral there is telling us the charge on it. Conversely, if I have iron that's lost 2 electrons, it's iron 2 or iron 2+. So with transition metals, that's again all that stuff in the middle, all of those other metals that don't have that really clear charge. We need to say what charge it has. So if I was writing iron in a compound, I'd have to know what charge it was. If I was writing the name of it, that's when this Roman numeral business takes place and comes into effect. Finally, so when we write the formula, and I kind of talked about this on the last slide, the formula for an individual ion, we simply put its chemical formula and then its charge. So the example here of chlorine. So chlorine has a chemical symbol of Cl. All the nonmetals in the Cl category have a charge of -1, so I can just put Cl-, or I could put Cl-1. I could even do Cl1-. Doesn't matter. It doesn't matter if it's -1 or +1. It all works. Likewise, let me erase this. Let's say we were doing something like that calcium I mentioned. So calcium, its chemical symbol is 2A. When I look at the periodic table, I see that all of the metals in calcium's column have a charge of 2+. So we would simply put 2+. And again, if you wanted to put like Ca +2, perfectly fine. It's technically 2+ because you're saying there's 2 positive charges, but this is perfectly reasonable. So you should now have enough information to do the worksheet that you're going to be dealing with. And yeah, should be good.